This tool has one job: pick up a 1,400-pound engine block, flip it 180 degrees, and never fail.
If we were unable to deliver, this would have been millions of dollars in downtime.
But our first attempt didn't just fail. It turned out to be physically impossible. To understand why our first design failed, we need to go back to the beginning. For years, a robot flipped these engine blocks without a problem, but then a new block was introduced that the old tool couldn't handle.
It had some features, some geometry that were not going to work. The original tool would crash into the block. The customer, they make engines. In this line, they have multiple different engine block styles that roll on a conveyor. After everything is assembled from one side, then they have two robots and an end-of-arm tool in between them that picks up this engine block and flips it over 180. Each of the blocks has locating features. None of the paired locating features on the end-of-arm tool matched up with the machined locating features on the block.
Initially, the customer wanted us to modify their existing tool to work with the new engine block.
My coworker, Jason, worked on that for about a year, trying to figure out how to modify the existing tool. We couldn't figure it out. Jason wasn't able to figure it out. Daniel wasn't. That was too hard of a problem. So we started from scratch, designed a new end-of-arm tool that would work with all 5 different blocks.
That reset the problem completely.
A couple things were uniquely challenging. Each of the blocks is unique in shape and in position and size of these locating features. It took quite a lot of thought to figure out a geometry that would work without using some moving component. Once I figured out the geometry that could locate the blocks, that kind of snowballed and solved a lot of the other problems.
Solving the locating geometry was a huge breakthrough, but it also exposed every other constraint we were up against.
There's 2 robots. They work as a team to lift this end-of-arm tool, but they only have so much capacity in just holding, but more importantly in rotating. These blocks weigh 1,400 pounds. The tool itself had to be sufficiently strong. Being strong means weight, which means a heavier load for these robots to carry. Creating a design that was well balanced was pretty important and also not that easy to do.
Once the engineering solution existed, the real work began.
We technically had our final design done months before we started fabricating, but the design that our customer bought off on was not the design that we delivered. We use a design through manufacturing methodology. So through manufacturing, we discovered different aspects that just weren't going to work or that we could improve. What we do is we start making drawings.
Before anything gets permanently assembled, we test fit the entire tool using tack welds.
There were different snafus. Our material vendor delivered some material that wasn't in the best condition. It looked like it had been left outside. So there was extra work added to remove rust. Then, while we were welding, one of our welders was kind of fresh on the dual shield during welding. Some of those welds didn't come out quite up to our standard and had to be ground or redone. These kind of problems show up in every job. That's kind of what we're good at, is pivoting, finding a different solution. Anyone who's ever built anything knows that there's always going to be small problems and tweaks. We had a very hard deadline to install this tool and not a whole lot of time to iron out the kinks of the design and fabricate. These engines are scheduled to go into high value machinery. If we were unable to deliver, this would have been easily millions of dollars of losses in downtime for not being able to produce the engine, and also not being able to deliver the end product that these engines are going into to their customers.
Once the last pieces finally aligned, it was time to put the tool under load and see if it could actually flip a 1,400-pound engine.
We decided to do the testing before powder coating. I had designed a little test fixture so that we could rotate these blocks around. It looks very cyberpunky. I am oddly proud of the design of the rotating fixture, which is kind of silly. You know, I fabricated that myself over the weekend because I had left this off, and then having it work pretty seamlessly to do the testing, I was definitely proud about that. Once those forks just slid right over the rails onto the base assembly, it's like, okay, this is gonna work.
All right, so here's the captain at the helm here, turning the gears. So that rotation will be done by a robot.
Getting the blocks, the heaviest block, onto the tool and being able to rotate it around, locating as it should, and not just falling out of the tool or breaking the tool was a huge relief.
What the customer never sees is how many of their requirements fight each other in the reality of manufacturing. It's our job to find the version that works.
I think that the amount of problem solving and solutions that we provided behind the scenes was not quite truly understood, because the feat of fabricating this in the amount of time that we had was incredible in itself. The customer is always going to have their list of requirements. Sometimes it's impossible, physically, geometrically impossible to meet all of those requirements. And that was the case on this design. Being able to come up with a way to truly get the optimal solution, that took a lot of work behind the scenes.
By the end, we had a tool that could do what the original couldn't.
I think that this one is kind of a perfect kind of comeback story, at least for us, because we truly say that we can solve any mechanical problem, and we were not able to solve that mechanical problem in the specific way that our customer wanted us to. And so being able to, instead of just, throw in the towel, say, hey, sorry, it's just not going to work, we fought as hard as we could to solve that problem in the way that our customer wanted us to, and had to say, we're going to just design something from scratch that will work. And then we did it. in the end, the end customer is happy.
This is Ape. We make the stuff that makes the stuff.